Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello students, welcome back to the TV learning program. I'm Teacher Pasco and today I will be with Senior 2 students learning chemistry, and we are continuing with unit number 6, the preparation of salts and identification of ions. And the lesson of today is preparation of insoluble salts. We have started the preparation of soluble salts, but the salts we know are not the soluble ones only. So we also have some insoluble salts, and today we will look at different methods we can use to prepare them. Here we have the objectives of our lesson, and at the end of this lesson, you should be able to describe different methods used to prepare insoluble salts, write and balance equations of the reactions that take place while preparing these salts, and you name various salts. We have studied the preparation of salts, and we will continue with the same topic. And we will have a chance of recalling how we name salts. And lastly, we will be able to state some of the uses of the common salts. Some of the common salts, of course, not all of them. So we are starting with a revision exercise, which goes back to the preparation of soluble salts. Revision exercise: complete the equations below. Sodium hydroxide reacting with nitric acid, copper oxide reacting with hydrochloric acid. Number 3, we have barium carbonate reacting with sulfuric acid, and next is hydrochloric acid reacting with calcium hydrogen carbonate, and calcium reacting with nitric acid. Here you should remember to write, you complete the equations, you balance them, and don't forget to include the state symbols. And then, number 2, you explain how you can prepare crystals of copper sulfate from 2 reagents of your choice. Here, what I can remind you is that the exercise we have here is exactly a copy of the homework I gave you on the previous lesson. So I thought that this is a good chance of having the homework corrected. So if you didn't get a chance of trying the homework, this is the right time. You can go on and you start with question number 1. But I hope that you manage to find time and try all these exercises. So without delaying, I want us to immediately start with the corrections. Question number 1, sodium hydroxide reacting with nitric acid. The equation we have is this one. It's a revision exercise. But as I said, it is also a correction of the homework. So we have sodium hydroxide reacting with nitric acid, and what do we produce? Sodium hydroxide is a base, and nitric acid is an acid. So here we should remember that the 2 reagents should be in aqueous solution, so we use aqueous sodium hydroxide, and aqueous nitric acid, we use a dilute nitric acid, and then we remember that when we react a salt, so when we react a base, and an acid, what do we produce? We always produce a salt and water. So the first product here is water, which will be in the liquid state, and the second product, which will be a salt, is, we know that the positive part from the base will combine with the negative part from the acid, and then we get sodium nitrate. As we know, all nitrates are soluble, so sodium nitrate will be in the aqueous form, dissolved in water. Equation number 2, we have copper oxide reacting with hydrochloric acid. So when copper oxide, which is solid, because it doesn't dissolve in water, reacting with hydrochloric acid, aqueous, what do we produce? We have a basic oxide reacting with an acid, so we produce a salt and water. So one of the products is water, and the other one is a salt, and the salt will be the positive part of the basic substance combined with the negative part of the acid, and then we produce copper chloride, which is soluble in water. Now, here it is necessary that we balance. If we balance, we have 2 chlorine atoms on the product side, but we have 1 in the reactant side. So we have to use 2 here. And we get our equation balanced. So we have copper oxide reacting with hydrochloric acid. We produce copper 2 chloride and water. And number 3, the third equation is barium carbonate reacting with sulfuric acid. What do we get when a carbonate reacts with sulfuric acid? It's barium carbonate. This one is not soluble. And we add sulfuric acid in solution. What do we produce when a carbonate reacts with an acid? 2 main products will be carbon dioxide and water. And then, apart from those 2, we also produce a salt. So we have water in the liquid state, carbon dioxide in the gaseous state, and then we get barium sulfate, which is solid. Barium sulfate is not soluble. And then we check if our equation is balanced. 2 hydrogen atoms, 1 barium and 1 barium. Our equation is balanced. Even the carbon, we have 1 and 1 carbon. The oxygen atoms, how many do we have? 3, 7, 4, 7. Balanced. And we go to the next. We have hydrochloric acid reacting with calcium hydrogen carbonate. As you can see, what will be the product? Number 4, we have hydrochloric acid reacting with calcium hydrogen carbonate. Like the carbonates, when a hydrogen carbonate reacts with an acid, we produce carbon dioxide, that is one of the products, and the other product is water, and these are produced with a salt. Here we have calcium chloride, which is soluble in water. And what do we get here? We have these are the products we have. Now we check if our equation is balanced. Here we need 2 chlorine atoms, so we use 2 there. And then we check if our equation is balanced. Here we have 2 hydrogen atoms, and here we have 2 hydrogen atoms. So we need 4, and then we put 2 here. Now we check if this is balanced. For the oxygen atoms, we have 6, and here we have hydrogen carbonate. Let's check if this is balanced. We have 2 HCl, so we have 2 chlorine and 1 carbon. We have carbon dioxide. The carbon dioxide, we need 2 here, and even the oxygen atoms like this, they are balanced. So we have 4 here and 2, making a total of 6. And the last equation we have is calcium reacting with nitric acid, a metal reacting with an acid, a dilute acid. So a metal will be in solid state, aqueous, and we produce calcium nitrate, soluble, plus hydrogen. We know what we produce every time we use a single displacement reaction in which an acid is involved. Okay? Now, the second question is asking to explain how we prepare crystals of copper sulfate from any two reagents of our choice. So we need a substance to give us copper and another one to give us the sulfate ion. Let us use H2SO4, and it reacts with copper oxide. What do we get? We get copper sulfate and H2O. And next to this, remember, the solution we get will be containing copper sulfate, and if we need to prepare crystals, then you have to evaporate some of the solvent to concentrate your solution and end up by forming some crystals. A saturated solution, when it is evaporated and evaporated again, as the solvent molecules will be reducing, crystals will form. Okay? Now let us start today's lesson, preparation of insoluble salts. We remember the different methods we use to prepare soluble salts. And we have seen that many of them are the reactions we have studied when we are studying the types of reactions. So even today, the methods we are going to study, they are those other types of reactions we didn't use when we were preparing soluble salts. For example, you remember the reaction which we called precipitation reaction. In the precipitation reaction, we combine two aqueous solutions and we produce a solid. So let us have the example here. We have sodium sulfate, which is in aqueous solution, reacting with barium chloride to produce barium sulfate and sodium chloride. So when two solutions containing soluble salts are mixed, it is possible to produce an insoluble precipitate, and that will be a salt. Here we have more examples. Let us try aqueous silver nitrate when it reacts with aqueous sodium chloride. What do we produce? I give you some seconds and you try to write the equation. Aqueous silver nitrate plus aqueous sodium chloride, and number 2 it is aqueous lead nitrate plus potassium iodide, and number 3 it is aqueous calcium chloride reacting with sodium sulfate. Some seconds and we give the answers. Okay, number 1, aqueous silver nitrate reacting with sodium chloride. Silver nitrate, you remember it is this one, in the aqueous state, reacting with sodium chloride, also in aqueous state. What do we produce? We produce silver chloride, which is an insoluble precipitate. So in the solution, you will find it as a white precipitate. When we will be studying the identification of ions, we will have a complete and clear demonstration of what happens when the two solutions are mixed. And I'm very sure that we have seen some of the examples like this one. So we produce a white precipitate and sodium nitrate, which will be in the aqueous state because this sodium nitrate is soluble. Okay? That one is soluble. So this is one way of preparing some insoluble salts. And the other equation is lead nitrate reacting with potassium iodide. Lead nitrate, it's this one, reacting with potassium iodide. Potassium iodide is also soluble in water. What do we produce? We have lead iodide, which is a yellow precipitate, and we add potassium nitrate. You should always remember to write the state symbols and make sure your equation is balanced. Is this one balanced? One potassium, one potassium. Iodine, we have one here, and here we have two. So we have to balance, then two, and we put 2 on potassium nitrate, and our equation is balanced. And number 3, we have aqueous calcium chloride reacting with sodium sulfate. Calcium chloride is this one, reacting with sodium sulfate. What will be the product, please? The products. Check if what you have given are similar to what I'm going to write. We have calcium sulfate, which is insoluble, plus sodium chloride. And as you know, sodium chloride is soluble in water, and we need 2 moles. We produce 2 moles. So that is one way, and the important method, the common one, of preparing insoluble salts. But there is another method we can use. Here we have a text explaining what we do. An aqueous base can react with a non-metal oxide to produce an insoluble salt. It's possible. We have the example here. And carbonates and hydrogen carbonates react with acids to produce salts, carbon dioxide, and water. We know that. But what we need here the most is the reaction of an aqueous base and a non-metal oxide. Let us take the example of calcium hydroxide. Here we have calcium hydroxide. You see it reacting with carbon dioxide. One question, do you remember the special name we give to a solution of calcium hydroxide? It's written somewhere here. It's called lime water. So lime water reacts with carbon dioxide. Remember, in biology, it is this lime water we use to test for the presence of carbon dioxide. What happens when you take carbon dioxide and bubble it in a solution of lime water or a solution of calcium hydroxide? The solution becomes, we say that it becomes milky. Why does it become milky? It's because we produce a white precipitate, this calcium carbonate, which is insoluble in water. So what we are studying right now, it has a connection with biology. It's very important in biology. You will need this many times. So we have calcium carbonate and water. And here we have more examples. Example number 1, lime water reacting with sulfur dioxide. What do we produce? Lime water contains calcium hydroxide. When it reacts with sulfur dioxide, what will be produced? Calcium hydroxide reacting with sulfur dioxide gas. What will be the product? And barium hydroxide plus carbon dioxide. What will be produced? So what we produce on the first equation is calcium sulfite plus H2O. And on this equation, we produce barium carbonate plus H2O, which is liquid. The equations we have, are they balanced? Yes, they are balanced. So there is nothing more we have to do on them. So we can go to the next slide. Preparation from a metal oxide and a non-metal oxide. It is possible to have salts, whether soluble or insoluble, as said here. Metal oxides can react with non-metal oxides at high temperature to produce salts which may be soluble or insoluble in water. We have the examples here. They are complete. They are common to us. Sodium oxide reacting with carbon dioxide, we produce sodium carbonate. Very simple and clear. Magnesium oxide with calcium carbon dioxide, magnesium carbonate. These examples, you will try them as a homework. They are very simple. You can complete them. So some of them, like sodium carbonate, is soluble in water. But because here we are not working in aqueous solution, then we don't give too much importance on whether they are soluble or not. Magnesium carbonate is not soluble. But because we are not working in an aqueous medium, then there is no need of considering whether it is soluble or insoluble. So it is also possible to use a metal oxide and you heat it at a very high temperature with a non-metal oxide and you get salts. On the next slide, we have the nomenclature. We have studied the nomenclature of salts in Senior 1. But here I want to remind you how we name different salts. So here we have, when we produce salts from hydrochloric acid, we produce salts which are called chlorides. For example, if you take hydrochloric acid, react it with sodium carbonate, you will produce sodium chloride. So it is a chloride. If you use sulfuric acid containing a sulfate, of course, you produce salts which are called sulfates. You use nitric acid, this one, you produce the nitrate. And if you use carbonic acid containing the carbonate ion, you will produce carbonates. If you use an acid which is acetic acid is an example of an organic acid. And in that case, you produce acetate, salts called acetate. We have more examples. If you use an acid containing iodide ions, you produce iodides. Bromide ions, you produce bromides. Phosphate, you produce phosphate ions, and so on. And then you remember how we name those salts. For example, we have a salt here. It is composed by sodium and sulfate ion, so it will be sodium sulfate. If we have one of magnesium and the nitrate ion, it will be magnesium nitrate. Okay? So it's very simple. It was just a simple reminder to let you recall how we name these salts. We have two more examples here you will try as a homework, as a practice exercise. Now, why do we study these salts? Why are they so important to us? Of course, you have to think that they have or they find some uses in our everyday life. So here I've tried to list some uses of the common salts, some uses of the common salts. So here we have sodium chloride, the table salt. So if I say table salt, then immediately you understand the use of that salt. So it is used as one of the important components of food in food preservation, for example, to induce the taste of food. You know that. It is also used when we are extracting or when we are manufacturing sodium metal and many other processes. There is a salt we call sodium carbonate, and it is commonly called washing soda. It can be used in the manufacture of glass, in textile industry, in paper industry. It can be used in laundry, so it has many uses. We know sodium hydrogen carbonate, which is another salt of sodium, which is used in baking powder. I think you like bread, so it is one of the ingredients we use when we are making bread. And it can also be used to reduce the acidity in our stomach. When you have a heartburn, do you know what is a heartburn? You can use sodium hydrogen carbonate and you reduce the acid, the excess acid. And here we have the homework. Take your time, note it down, and then you will try it when you get time. So we have copper oxide which dissolves in dilute sulfuric acid to form. You will name what is formed. The metal oxide, when it reacts with carbon dioxide at a very high temperature to produce both soluble and insoluble salts, is the statement true or false? And you complete those equations. Calcium oxide reacting with sulfur trioxide, magnesium oxide reacting with carbon dioxide. And we have another question, sub-question C. You will name the products we form in sub-question A and sub-question B. And the last, you choose the right answer. The salts we obtain by the reaction of sulfuric acid, are they called chlorides, carbonates, acetates, or there is no answer in the suggested answers? You will choose the right answer. Thank you very much for your attention. I will see you next time.